Hey everyone, we're going to start today with a review of theoretical probability of compound events. But before we do that, let's talk real quick about our two vocabulary terms, or the two different types of events. So we have independent events and dependent events, okay? So independent events are events for which the outcome of one event does not affect the outcome or the probability of the other. So like if you toss two coins, right? One does not change the outcome of the other. Or if I roll a die or a number cube and toss a coin, those are independent from each other, right? And then, so we're thinking about like an independent woman, right? She doesn't need anybody. She's on her own. So the event happens on its own. And then dependent events are events for which the outcome of one event affects the probability of the second. So like a dependent, like my daughter is dependent on me, and what I do may change what she does, okay? So what keywords tell you if an event is independent or dependent? So if it's independent, it sometimes may say with replacement, okay? So if there's a plate of cookies and I take a cookie and I change my mind and I put it back, then the probability is not changing. So I take it, I hold it, I put it back. So that's with replacement, and the probability is not changing, okay? Dependent events are without replacement. Or it'll say without putting it back, or it'll just be a scenario where some person takes a candy and then someone else takes a candy, okay? If they're taking a food item, they're not going to put it back unless it says they are, okay? So most of the time it'll have wording such as this, with replacement or without replacement. So let's look at some examples. The first one says, to choose the team leaders for a math project, Mr. Garcia randomly drew names of 3 students. If there were 9 girls and 6 boys in the drawing, what is the probability that he drew 3 girls' names? Okay, so there's 9 girls and 6 boys. So 9 girls, 6 boys. So 9 plus 6 is 15 total students. And we want 3 girls. So girls, girl, and a girl, okay? That's what we're looking for. So if the first one that's chosen is a girl, so the probability is going to be 9 out of 15, okay? So say we're looking at, I don't know, my 5th period class. If we choose Monica first, okay, so she's a team leader. Well, now her name is no longer in there, right? She can't be on 2 different teams. So this is just a scenario that's saying, okay, so now there's 8 girls and there's 14 people's names left because Monica's already a team leader, right? So now the second girl, let's say we chose out a name and it was, let's see, so there's 8 girls left out of 14, right? Okay, so now we took Rashayla's name out and she's the next team leader. So 8 becomes 7. Now there's 7 girls' names in there and there's only 13 names in there now, okay? So now when we choose the third girl, there's 7 girls left out of 13. Right? So, and then what do we do with probability? Well, we multiply probabilities. So we have options. We can simplify them individually, or you can simplify diagonally. So I'm going to start individually and say, okay, 9 and 15 are both divisible by 3. So 3 over 5. Sorry, I don't know why I did that. But that's a 3. Okay, so 3 out of 5. These are both even, so 8 divided by 2 is 4. 14 divided by 2 is 7. So now I'm down to that. So that's looking better. And then if you're multiplying, if you guys remember, if we multiply, we can take common factors out of the diagonal, okay? So I am going to use a different color so it makes it easier for you to see. So 7 becomes 1 and 7 becomes 1 because I divided them both by 7. So now we're going to multiply across. 3 times 4 is 12 times 1 is 12. And then 5 times 13, 3 times 5 is 15, 5, 65. So 12 over 65. All right, moving on to the next one. We have a game is played with a fair spinner. One spinner has 4 sections numbered 1 through 4. The second spinner has 5 sections, okay, with all of these colors. All right. What is the probability of spinning a 1 on the first spinner and the color green on the second? So if we're talking about 2 different spinners, this is going to be independent. Okay, top one was, darn it, sorry, dependent, right? Because our total changed. Darn, I'm having issues. Okay, so I'm going to list these out. The first spinner has sections numbered 1 through 4. So 1, 2, 3, 4. Second spinner has colors: red, blue, green, orange, and brown. Okay, so it says I am looking for a 1 on the first spinner, and I'm looking for the color green on the second. So 1 and green. Okay, so 1, there's 1 out of 4 times green, dagnabbit, 1 out of 5. 1 times 1 is 1, 4 times 5 is 20. Okay, so that's much easier, right? Because you're not having to change your total. Let's look at the next one. It says Sherry had a bag containing 1 red, 3 green, 5 purple, and 6 blue tiles. What's the probability of drawing a green, not replacing it, and then drawing a tile other than red? Okay, not replacing it. Dependent. Those keywords tell us that. Sorry. Okay, so we have 1 red. We have 3 green, 5 purple, and 6 blue. So 6 plus 5 is 11. Plus 3 is 14, 15. And let's see, we want a green. We're not going to put it back, and then we want not red. Okay, so let's look at this. We want green and not red. So green would be 3 out of 15, and then not red. Okay, but I took a green out, so that leaves 2 green and 14 total. So now we're saying not red. Oh, you guys won't be able to see yellow, sorry. So not red. So any of these, right? So 6 plus 5 is 11, 12, 13. So 13 out of 14. Okay, so we're going to multiply, and that will give us our answer. So 3 times 13. Oh, wait, hang on. I can simplify here. 3 over 15. So divide by 3, I get 1. 15 divided by 3 is 5. This will make this much easier. 1 times 13 is 13. And then 5 times 14. 5 times 4 is 20. 5, 6, 7. So 70. So 13 over 70. All right, so hopefully this is a good review of your theoretical probability of compound events, making sure we're really thinking about, so not replacing it told us that that was dependent, right? The first situation, we just understood it was dependent because of this situation. If we're choosing team leaders, I can't be the team leader of 3 teams. That's not possible. Okay. And then this next one, the second one, was just the scenario. If it's 2 different spinners, it's not going to affect each other. Even if it's 1 spinner and we spin it twice, that still doesn't change our total, because it's not like we're taking a piece away from the spinner or changing a color on the spinner, okay? So make sure that you're really thinking about that before you solve the problem. And I think it's a good practice to either write independent or dependent out to the side so that you remember what you're doing. So again, with dependent, our total changes as well as one of the options, okay? So, and it does seem to work well writing this out so that you know what you're looking for, okay? So keep practicing. Make sure you come in and ask for help if you need it. I can pretty much guarantee there will be one like this on the STAR test, and of course, one coming up on your next test, all right? So ask questions if you need help.